Thanks, sir. Word problem. It's a little different than the ones we looked at last week. First of all, we have to be able to interpret this. Okay, it says the sum of two consecutive integers is 1 less than 3 times the smaller integer. Find the two integers. So there's some words here that we have to understand before we can really go anywhere with this, right? First of all, oops, there we go. First of all, what does it mean to say an integer? Yeah, it's a certain kind of number. It's a subset. We got this set of all possible real numbers, and we'll talk about this as we get into kind of algebra 2 stuff. We'll focus on this a little bit more. You've seen it in the past a little bit. We'll hit it a lot more this year. We got this set of all the real numbers, and then we can break those into subsets, right? Smaller sets of the big set. We can talk about rational numbers and irrational numbers, and we'll remind ourselves what those are later. Subset of rational numbers would be something like, for example, whole numbers, right? We all know what whole numbers are. 0, 1, 2, 3, 4, etc. 0 plus the natural numbers or the counting numbers. So what are integers then? Integers are just a different subset of rational numbers and real numbers. What are the integers? Remember? If I draw a number line, here's how I like to remember it. If I draw a number line, and on the number line, I've got 0, and then I've got a bunch of, I put a bunch of hashes, don't I? Right, like I would put a hash there, and a hash there, and a hash there, and so on. What's that one correspond to? That's 2, 3. How about that one? -1. Integers are just the set of all those hashes, right? So it's the set of positive and negative whole numbers. That's it, okay? So then what does it mean if we say, now let's expand that, instead of just integers. So integers would be positive and negative whole numbers. What does consecutive mean? Yeah, next to each other, right? So give me an example of 2 consecutive integers. 1 and 2. What's another one? 0 and 1. Give me, what about 2 negative ones? Negative 3 and, no, because those aren't consecutive, right? Negative 3 and what? Negative 2, or negative 3 and negative 4. Okay, that makes sense? Okay, so we want to find out what these numbers are. This is a little different approach, though. We got to set up a variable. Well, what is it that we're being asked to find? The 2 integers, right? So those are both unknowns. Okay. Let's let one of those 2 integers be x. Okay. So how about if the smaller one we call x, right? Does that make sense? That's one of the things we're trying to find. And by the way, this would work the other way too. I could let x be the larger integer also. It doesn't matter. So we're going to let x equal the smaller integer. Then what would the larger integer be, by the way? So like, for example, if x was 3, what's the next consecutive integer? That's 4, right? So how would I say that? If the smaller integer is 3, the larger integer is 4, right? Do you agree with that? If the smaller integer is 10, what's the larger integer? Okay, how are we getting that? What'd you do? We added 1, right? Because we want to go to the next hash mark, so we're going to add 1 to get there. If the smaller integer is negative 20, what's the larger integer? Negative 19, isn't it? Right? We're going to move 1 to the right. Everybody agree? Okay, now now extend that thinking. You're all thinking about this correctly. If the smaller integer is x, what's the larger integer then? Well, but without introducing another variable, just in terms of x, what would it be? X plus 1, right? Isn't that the pattern that we established? You just add 1 to get to the next integer. Okay, so now let's kind of color code this, and let's see if we can come up with an equation. What did we say last week? There's kind of a loaded word in story problems or word problems that almost always corresponds to an equal sign. Is. Okay, good. So there's is, right? So we've got an equal sign. Let's look on this side over here. The sum of 2 consecutive integers. So that's the blue statement there. How am I going to say that in terms of my variable? X plus 1, right? I've got the first integer was x, the second one was x plus 1. The sum just means I'm adding them up, right? So we've got x plus 1, right? On the left is, what about the right? Let's go over here. How do we say this? 1 less than 3 times the smaller integer. So, okay, so 3 times the smaller integer would just be 3x, right? But if we want to do 1 less than that, then I've got to take 1 away. Do you agree? Okay, so now it's a piece of cake from there, right? Like I told you last week, word problems almost always work out to be easy math problems. That's not the hard part. The hard part is getting to the equation, right? Once you get to the equation, you guys have done a bunch of problems like that. That's no big deal, right? We've got a bunch of x's, but we could just combine like terms until we get a single x, and then we isolate it. Okay? And I'll leave that part up to you. What else? Other questions? It's a good question. Yeah. Anything else? 14. Let's look at 14. Okay. Okay, another word problem. Well, let's see if we can at least start to set this thing up. Okay, what about that? So the length of a rectangular picture is 5 inches more than 3 times the width. Find the dimensions of the picture if its perimeter is 74. Okay. So what are we being asked to find? The length and the width. Good. Okay. So now notice something up here. We could really pick either one to be x, but one of them is going to make more sense. The width, isn't it? Right? Because they tell us that the length is 5 inches more than 3 times the width. So we're being asked to write the length in terms of the width, right? So does it make sense then that we really want to let the width be x or w, whatever you want to call it, our variable, right? Okay, so first things first then, we know x equals the width, right? I'm going to turn that around. You'll see why. So the width equals x. What's the length going to equal then?
3x plus 5.
It's 5 inches more than 3 times the width. Okay, good. So would everybody agree that 3 times the width would be 3x? But it's 5 inches more than that, so we got to add 5. So we've got expressions for the width and the length, right? Now what about perimeter? This takes us back to geometry. What's the perimeter of a rectangle equal to? How do we find it? All the way around it, right? So if we've got a rectangle up here, and let's just call, for now, let's just call this the length and the width, right? Just in general, what is the perimeter in terms of the length and the width of the rectangle? You remember, if I'm going to go all the way around, if an ant's going to start here, he's going to walk all the way around this thing. How far is he going to walk? 74 in this particular problem. But what about in terms of the length and the width of the triangle?
Length times 2 width.
Okay, yeah, he's going to walk across. So he's going to walk the width, then he's going to walk the length, then he walks the width again, so he's walked the width twice, and then he walks the length again for a second time. So everybody agreed that we could write the perimeter is really just 2 times the width plus 2 times the length for any rectangle, right? Now our rectangle we know some stuff about, right? We know that the width is x and the length is 3x plus 5, right? So we could write, instead then, we could say something like, okay, 2 times the width plus 2 times the length. Isn't that whole thing just our perimeter? right? And that is equal to, we know that the perimeter is 74, right? So here's the word is, so the perimeter equals 74. So there is the equation. Everybody agree that we're going to solve? Does that make sense how we got that? Okay? Okay, you'll get some extra practice on that on the Moodle stuff, so I don't mind going through another example. And then you would just, simplify, collect like terms until you can point to a single x and then you isolate it, right? Okay, and you've had quite a bit of practice with that. You get a little more too. Okay, what else? Yes, ma'am.
So on number 8, I did the math, but then I got to from
Okay, number 8. So this is the one involves a decimal. Yeah, let's look at this one. Number 8. All right, number 8 says negative 0.5 g plus 13 equals 3g. Okay? So the decimals make it a little bit awkward. What are we going to do with this? There's a bunch of ways we could go with this, and none of them are necessarily the right or the wrong way. Dealing with the decimal. Suggestion, yes ma'am? Okay, you could turn it into a fraction. Yeah, that's not a bad idea. We know that 0.5 is exactly equal to what fraction? 1/2. Okay, so what if we wrote it like this? Negative 1/2 g plus 13 equals 3g. Now, what's our trick? When we've got even one fraction involved in an equation like this, we can still clear the fractions, right? Even if it's just one. We dealt with harder ones last week where we had multiple fractions. But what was our strategy for clearing a fraction, or clearing the fractions? Good, we're going to multiply by the least common denominator. What's the only denominator? 2. So what's the least common denominator? 2. That's it, right? So if we distribute a 2 through to both sides, what's going to happen? Okay. Well, 2 over 2 is what? 1. Remember our trick. So 1 times 1 is 1. So I just end up with a negative 1g, right? How would I write that? Do I need to put the 1 there? No. Everybody agree that first term just becomes a negative g? Make sense? Okay. Distribute the 2 over to the 13. Well, we don't have to do any fancy fraction stuff there. What's 2 times 13? 26. And then on this side, 2 times 3, 6. So I just get 6g. Everybody agree? Okay, and now from there on out, what would I do? Good, I'm going to push the g's to the right, because 6 is more than negative 1, right? So we'll add g to both sides. Good. And then we get 26 equals 7g, right? Last step? Divide by 7. Yeah. Now, if I divide both sides by 7 to get that g by itself, look what happens. I get g equals 26 sevenths. Is that a bad answer? It's fine. It's fine. What suggestion? Could we go any further with it? Not really. We don't really want to write this one as a decimal, do we? Because 7, we're not going to get, we're going to get like an infinite decimal that, it's irrational. It's never going, or it's, it's rational, but it doesn't give us a nice, neat decimal, does it? Right? And so we don't really want to write it as a decimal. We prefer to just leave it like this. If our answer was like 3.5, well, that's no problem. Then we can, that turns into an exact fraction, and that's okay to deal with, to write as a fraction or a decimal. Either one's fine. But this one doesn't play well as a decimal, so we'll just leave it as a fraction. Much easier, and that's an exact answer. Okay? That makes sense? That's probably a good way to do that one. Yeah, yes, sir.
I just had a graphic question.
Okay. Sure.
So, I'll just, the answers I got was...
Which one are we looking at? 21, okay. Okay. Oh, yeah, this is a good one. Let's look at this one. And it's a little bit strange. That guy, right?
Yeah.
Okay. It's a little bit strange. Now, normally when we graph an OR inequality, but not always, kind of the standard would be we'd get arrows, we get vectors pointing in opposite directions like we worked on the phone. It doesn't always have to be that way. Exactly. So let's look at this problem. The math isn't really very hard. It's just a matter of how do you interpret the graph, I think, is the hard part. So what do I do if I've got an OR compound inequality? I just deal with them individually, right? So I'm just going to go ahead and put a dotted line down the middle, kind of splits this thing up into two parts. What do I have to do on this side to isolate the y? Add 6. Yeah, just add 6. If I want to rewrite this, what's another easier way of saying y plus negative 6? Y minus 6. So maybe we want to just rewrite that as y minus 6 is greater than or equal to negative 13. So we add 6 to both sides. If I add 6, what do I get? Y is greater than or equal to what? Negative 7. Okay, everybody agree that's part of our answer? Okay. Or, what about the other side? What are the two steps in order to get the y by itself here?
Subtract 8.
Subtract 8 and then
Divide by -3.
divide by -3. Okay, good. So if we subtract 8, those go away. I get negative 3y equals, what's negative 7 minus 8? Negative 15. Good. Same thing as negative 7 plus negative 8, right? Okay. So then all I have to do is divide each side through by negative 3, right? So I get y, what's negative 15 divided by negative 3? But what do I have to do? Good, gotta flip the inequality, don't I? Because I divided by a negative. Good. So because I had that negative there, and, I had an equals there. That's not supposed to be equals, is it?
No.
It's supposed to be a greater than. It's going to flip to a less than, though, isn't it? Right, so my final answer then is y is greater than or equal to negative 7, or y is less than 5. Okay? Now think about an or for a second as compared to an and. And is more demanding, right? If I say this has to be true and that has to be true, they both have to be true at the same time, right? But if I say this has to be true or this has to be true, only one of them has to be true, right? As long as one is correct, one is true, then we're fine, right? Okay, so what if we graph this guy then? Let's graph this one. Let's make this one yellow, how about? So y is greater than negative 7. So if I go down here to negative 7 on the number line, how am I going to graph that one?
You put a filled-in dot.
Okay, filled in dot because I've got an equal sign with my inequality, and I'm gonna extend in which direction?
To the right.
To the right, because it's greater than. Greater than means to the right, numbers to the right. Less than means to the left, right? So it looked like, so that inequality, oops, looks like this. Okay? Or, what about this one? Let's make this one blue. So y is less than 5. So if I go up here to 5 on the number line, what's that one going to look like? Good, because it doesn't include equals. I got an open, and I shade which direction? To the left. Okay, so now think about this. Let's think of an ant here. If an ant has to be standing on the yellow graph or the blue graph, what can you tell me about that?
They're greater than equal to 7 plus.
Let me ask you this, is there any place where the ant could stand on the number line where he wouldn't be on either the blue or the yellow part?
No.
There's not, is there? So what's that tell you about the solution then? Yeah, it could be anything, right? It's all real numbers. So if we're going to graph this thing then, it doesn't need to be that complex, right? We don't really care about the fact that the yellow and the blue overlap in this way. If we're just trying to graph the solution set, that's all we're doing. We're trying to graph all the places where this is true or this is true, right? I would just graph it, what, blue and yellow make green, so let's make this one green. So the solution would really just look like this. It's just the whole real line, okay? That's all we need to do. Now, what if we had made this an and statement instead, right? What if we had taken the same problem and it had been an and statement? So this or was replaced by and, right? What if we did that?
And only places where both the blue and blue are in white.
Good. Then I could only pick the places where the ant could stand and be on both blue and yellow at the same time, right? Where would that be? Well, wouldn't that just be starting there? I could go over to, but I couldn't include that endpoint, could I? Because it's actually not blue. It's empty, right? See the difference? Okay. So an and is more restrictive. Or is more forgiving. It includes more stuff. Okay? Make sense? What else? What else? Any questions? Okay? Okay, good. So then here's what I'll have you do. Come on up and grab a Chromebook. Let me see how we're doing it. 2, 1, 2. So I can get 2 more. I think we're too short. I'll go grab 2 more. Everybody grab a Chromebook. Yes, ma'am.
You don't need to grab one for me, I'm on my own computer.
Oh, perfect. Yeah, I'll grab one. So grab a Chromebook, log into Moodle. Let me show you what you're going to see when you get there real quick, before you jump up and do this. Here's what you should see. Let's see, is that Moodle? Yeah. Okay, so here's essentially what it's going to look like. I'll make it look like a student. So there's what you're going to see. There's a bunch more stuff to come. There'll be some links to the videos. I'll put those on today. Topic 1, that's going to be algebra review resources, but the algebra review practice. This is kind of our practice means homework, essentially, right? So this is where all the homework is going to be for our algebra review. Well, right now there's only one assignment in there. There'll be another one coming up real shortly, but this will be enough for you for today, I'm sure, if we're in class. If you click on that, it's just going to ask you if you want to, I've already started it, so ask me if I want to continue the last attempt. When you start it, it'll say, do you want to, attempt the quiz? And it calls everything a quiz. It's not a quiz, right? Then you would just click on that. Here's what you would see. If you did that, it would look like this. Notice that it's got a little section up here, the quiz navigation. So this is the first part is solving multi-step equations, the first 6 problems. The last 4 problems are just solving absolute value equations. And this is what you see. So just a quick reminder before you jump into this about what this answer box is all for in Moodle. So in Moodle, when you see an answer box like this, instead of one that's expanded into the algebra template, the reason for that is that, well, you might want to be able to just put in an answer more quickly. Like, for example, if the answer were 9. I'm just filling in the blank always, right, in Moodle. I don't write x equals 9. The x equals is already there. I'm just filling in the missing part. So if the answer were 9, I would just type in 9 and check it. Oops, it's not, though. Okay, so it told me it's wrong. Now, all this stuff down here, these are really old questions, but it's still kind of useful. This is just a quick reminder about what you do if you're solving an equation that has variables on both sides, kind of a thing, right? This just reminds you about the order of things that you do. More importantly, probably, it tells you that the correct answer is 2 instead of 9, so I made a mistake. Just try another one. I just load another one up, and I can try again, right? If I want to use a fraction or something for an answer, I can just click on that little icon, the little square root icon, and that's going to pop up this algebra editor, right, that you guys have seen before. And these are all the different templates that you can click to get them into the algebra editor. Okay? Notice that there are, in some cases, there's a menu to be pulled down. Like, so for example, on this stuff up here where your fractions or exponents, that little arrow says there's other options. If I click on that, I can see that there's also a subscript. that I could get to. You don't need to on this assignment, but later you might. For the parentheses, well, the one you use most often is regular parentheses, so it's right there. But if you click on that little arrow, you can see that there are other options too, like absolute value bars or brackets or all kinds of things, right? When you go over to the operations, well, division's the one that's up there because that's the one that's not directly on the keyboard. But if you open up that little menu, you can see other stuff too. Like, for example, less than or equal to and greater than or equal to are not on the keyboard. The less than and greater than are, right? Those are just the sideways arrows. But the equal to ones, you'd have to pull them out of the algebra editor. Okay, does that make sense? Okay. If you're working on a tablet or a phone and you want to use that fancy handwriting recognition tool, you just click on that and then you can draw in there. Right? If you want to go back to the keyboard, you just hit this little icon right there. Okay? Make sense? You'll have questions, but I think that'll get you going. Grab a Chromebook and get rolling. Who needs Chromebook? There you go. Okay, if you have trouble logging in or something, come on up. Trouble logging in?
I don't know what to put in there.
Okay, come on up. I'll show you. We'd probably maybe we have to make you an account. Grab your Chromebook there.
Maybe.
Let's see what's going on here. Let's see what's going on right there. Okay, so yeah. Okay, so you haven't used the Chromebooks before? Okay, how does that work? What's your login for the Chromebook?
This, on the Chromebooks, it's your email login.
Okay, so, but it's your email. It's like your
Lunch number.
okay, and then if you've never used it before, what's your password? Is it?
Usually it's your first initial, last initial, then your lunch number, and it's lowercase all.
Okay. Okay, so let's try this. So put in your...
I don't know it.
Okay, I can tell you. I think I know it. I think I know it here. Let's see.